got a fungus. 10. We've got a fungus, an Aspergillus, used to produce citric acid in fermenters using sugars as substrates. Citric acid is an intermediate in a metabolic pathway as shown. So you've got sugars with enzymes, goes to intermediates, another set of enzymes take us to citric acid, and then the actinase enzyme produces isocitrate. Okay. The actinase enzyme requires iron to function. Explain why the growth medium used to produce citric acid should not contain iron. Well, so what we're trying to do is to produce citric acid, which means I want to go here and that I do not want to go any further. So I basically want to inactivate or prevent, inhibit, stop this enzyme functioning. Okay, it says that the enzyme requires iron to function. So why do I want to make sure there's no iron present? So the actinase, I'm not sure how you pronounce that, whatever, that enzyme does not remove citric acid to isocitrate, because you didn't want to make that in the first place. Okay, the optimum temperature for citric acid production by Enesia is 30 degrees C. Explain why less citric acid would be produced if the temperature in the fermenter was reduced. Okay, optimum temperature. That means that that's the optimum for the enzymes. So lower temperature means enzymes below optimum. So less function, less activity. That's it. Okay. We've got your fungus grown in a fermenter over an 8-day period and the pH was measured every 2 days. The results are shown in the graph. Predict the pH at 10 days. Now that means that you're going to have to be prepared for in your exam, either taking a ruler with you or better in this one, because this is a straight line, these should give you the relationship. Okay, so at 4 to 6, you drop down by 1, 2, 3, 4. Oh, we're going for 5 on the scale. And 6 to 8, you went 1, 2, 3, 4, 5. So you're going down by 5 on the scale each time. 2, 3, 4, 5, which is 1 full pH. So if this is at the moment 4.2, you're expecting it to be 3.2. Okay, you could also, you could have extrapolated with a ruler, drawn this to 10 and then drawn this along to make this 10, and you would had to have been very neat and careful with your measurements. So from the date in the graph, I think you're easier just taking it down that way. They're not going to give you much give because it is the same every time. Okay, suggests a reason for the change in the pH observed. Well, you're trying to make citric acid. It's a very odd question. So you've got increased concentration of citric acid, which is an acid, which would lower the pH, and that's you. Okay, state a variable other than temperature or pH that should be monitored and controlled in this process. So there are several ones that you could put in here. So you're expecting oxygen's probably your best one, making sure that they're kind of happy with the level of oxygen that you need in there. But you also could be monitoring the sugar level, because the sugars are your substrates that are going in at the beginning. You could also measure waste product production as well, because you want to make sure that they're kind of healthy. It says any variable, so just something that is rational and reasonable in that process. Explain what was necessary to sterilize the fermenter before you added your Aspergillus. Okay, so it's to remove any other microorganisms. So there's no competition and you don't get contaminated product. I didn't check exactly what they said in the mark scheme for those ones, so I think that's probably actually 3 marks and you only needed 2 of them. Okay, that's the question.